Internet of Things is known thing from a very long back. So I'm not going to depth more. So just let me cover a little bit up higher level about the 6LowPAN is one of the emerging technologies going on around the world, and the CoAP and the MQTT. So first I will start with an 6LowPAN. So what is the 6LowPAN, and where we are going to use the 6LowPAN and all these things. So we all know very well. So the 6LowPAN means it's from IPv6 enabled low power personal area network. So the name itself will start with IPv6. So it is derived by an Internet Engineering Task Force, IETF. So let me go with why IPv6. Why not IPv4? We know very well about IPv4. It's a 32-bit IP address, and only 4.2 billion of an IP addresses can be generated. It's not at all enough. So it makes us to move with an.
Adarsh, can you hear me?
Yeah, I can hear you.
Yeah, Adarsh, I suggest that we record this session so that maybe if someone wants to listen to this later, they can.
Yeah, sure. So Vijay?
Yeah, it's recording. I'm recording it.
Okay.
Okay.
Thank you.
Fine. So 6LowPAN. So let me give brief idea about the 6LowPAN. What this 6LowPAN means.
Adarsh, can you be little bit louder? Your voice is a little bit low side.
Yeah, is it audible now? Hello?
It's audible now. You can carry on.
Okay. So, yeah, 6LowPAN. It's a completely an sub-gigahertz protocol and low power protocol. So the main advantage of an 6LowPAN is like it will use of an open standards such as like an TCP, UDP, HTTP, CoAP, and MQTT sockets and all. It's a completely an end-to-end IP addressable node. So no gateway is required here. A router will connect 6LowPAN network to an IP. That's the main advantage. In the diagram, we can see. So there's a comparison between TCP/IP stack and the ISO SLA stack and the 6LowPAN protocol stack. So 6LowPAN layer stack is completely a 5-layer stack. We are not making use of an presentation section layer. It's not required because only one kind of an application will be running on the stack. So the adaptation layer, which will come in between the network layer and the MAC layer. So the adaptation layer mainly take care of an header compression, fragmentation, and the layer 2 forwarding and all. So I will come to that point. Yes. So mainly, let me tell what are the benefits of an 6LowPAN. So it's a low power radio frequency with an IPv6. It's completely the wireless embedded internet, and open, long-lived, and it's completely a reliable standards it's maintaining, and easy learning curve. It's very easier, simpler thing, and transparent internet integration, and network maintainability, global scalability, and end-to-end data flow. Everything will be very smoother in the 6LowPAN stack. So just we are very familiar about this is completely a mesh technology. So we are very familiar about an IPv6 neighbor discovery process and all. The same thing will be followed here in 6LowPAN, also the IPv6 neighbor discovery process. So IPv6 is the format of a neighbor discovery brains. So one mapping protocol, actually this is defined in an RFC 4861. So there is an IETF standard. So this will define the interface between the neighbors, and finding the neighbors means neighbor solicitation, neighbor acknowledgement, and finding the routers means the router solicitation, and especially the router advertisement, and also address resolution using neighbor solicitation, neighbor advertisement, and detecting duplicate address using the same process. So, and neighbor unreachability detection, and DHCP v6 means dynamic host configuration protocol version 6 may be used in the conjunction with an neighbor discovery process. We all know that 6LowPAN maximum payload size is like an 127 bytes. So it's a standard of an IEEE 802.15.4, which uses the frames of 127 bytes, and size of an IPv6 packet is like an 1280 bytes. So IPv6 is 1280 bytes. So that has to be compressed. That has to be reduced to an 127 bytes. So here there is a requirement of an header compression and fragmentation process to reduce from IPv6 packet 1280 bytes to an IEEE 802.15.4 standard 127 bytes. So 6LowPAN MAC header, actually it will cover like an 25 bytes. IPv6 header will cover like an 40 bytes, and payload we will get the size of an like an 62 bytes, and UDP header like an 1 byte. So The main process taken care by 6LowPAN is to reduce. It was to perform the header compression, fragmentation, routing, auto configuration process. That is what an adaptation layer. So we are adopting this adaptation layer in between the network layer and the MAC layer. So moving to the next part. So fragmentation, I'm telling you about the fragmentation. Just I will give you a bit of brief idea about the fragmentation process. So when there is a packet is like a very higher data size, like IPv6 packet is of 1280 bytes, it has to be get fragment actually. So subdividing a larger packet into several smaller ones is often fragmentation. The fragmentation process here, it will be taken care by the adaptation layer of 6LowPAN. Reassemble the packets in correct sequence and end-to-end called as a defragmentation process. Both it will be taken care by adaptation layer. Just to go in bit technical, so in depth. First fragmentation header like in 4 bytes that use in 6LowPAN fragmentation mechanism, and subsequent fragmentation headers within 5 bytes, including extra byte of an offset field. And datagram size file is used to simplify the size of the entire IP packet before adaptation layer fragmentation. And the datagram tag will be maintained. This tag will be helps to identify the fragmented packets. Let me give you some idea about the header compression. So IPv6 header length. So IPv6 header will be consistent.
Can you give like, I know it's technical, right? Can you also add some examples, right, between where it is more beneficiary, because this group has both the technical and business. So if you can also add some flavor of a business, right, where the 6LowPAN benefits are, also it would be great.
Yes. So mainly application where it will be utilized is like an so nowadays we are know that everywhere the devices will be utilized. So multiple in number of billion of an end devices. Actually I have not covered that part. So embedded devices will be utilized. Each embedded devices, each microcontroller, which having a very less memory size, which is in kilobytes, those memory devices will be consisting an IP address. Those devices will be assigned with an IPv6 address. This stack. So, for example, in our PC or else in our laptop, we are going to run an TCP/IP protocol ISO layer stack completely to get connect with an internet. So now the requirement is each and every devices has to connect to an internet. Mainly the requirement is to collect the real-time data. For example, industrial applications. So in industrial applications, the data will be captured. Like in, for example, the boiler data will be captured and it will be pushed to a database. So if I am pushing the data to the database, and if I'm reading for every 5 minutes once, so I'm getting the 5th minute data. I'm not able to get the real-time data. If the devices are with IPv6 enabled, if the devices are connected to an internet, so each devices will be identified by its own IPv6 address. So within the network, so I can get the data in real time by making use of the 6LowPAN adaptation layer stack. So for these to build these kind of an applications, there are multiple operating systems are there nowadays, like a Contiki operating system, OpenWSN, and Mongoose operating system, RIoT, different kind of multiple operating systems are available to build an end devices. Moving to the next one. So this is an, as I mentioned, like an RPL. So as I told, it's a self-organized network. So DODAG means your destination-oriented direct acyclic graph. As I mentioned, this is mainly responsible to create a mesh network. So already I mentioned about the neighbor discovery process and all. The RPL is the one of the routing protocol which helps to create a mesh network. So coming to the application, so I'm not going to keep only one device to connect a network. Where I want multiple devices, I want for each multiple device, I want to create a mesh network. For all the mesh networks, I want a single router. So that is what let's sync, and all the end devices will be there. So this is the one of the routing protocol which supports with an 6LowPAN stack. Actually, a routing protocol for low power and lossy network. This routing protocol will support with an very less memory available microcontrollers. So DODAG information object. So where the information object is to responsible to join the end devices to a network. In industries, I want to build a mesh network. So where multiple devices like a boiler, like a cooler, And all the devices will be with its own unique IPv6 address. All the devices as to get connect by its a mesh and multi-op process. So for this purpose, the routing protocol RPL will be very useful. So DODAG information solicitation and destination advertisement object, DODAG destination oriented direct acyclic graph means to avoid the packet loss, to means cyclic packet loss, and all to avoid this. There will be an acyclic graph creation, self-healing will be taken care by this routing protocol RPL. So just to give some more information with a 6LowPAN, actually the next upcoming one is 6TISH. So 6TISH is like an time synchronization channel hopping process. So we all know very well that an interference is very much high, as like, and there is a Zigbee is going to run and 802.15.4 standard, 6LowPAN is going to run an 802.15.4 standard, and multiple protocol, multiple waves will be keep on running because of the same channel, and all there a lot of interference will be there. To avoid that one, we need the channel hopping process in this stack. So this is the 60 is the upcoming new technology that's an time slotted channel hopping process. So this is in amendment with the MAC layer actually. So this is below the adaptation layer. There will be an in combination with the MAC layer. There's a scheduling process is the gap. To fulfill that gap, the 60 process will be utilized. So the one of the operating system supports for N60 is like an OpenWS, and is the operating system support for N60 process. So let me move with an CoAP protocol. So this CoAP protocol is also based upon IETF standard. So Internet Engineering Task Force, and completely the RSC standard RSC is like a 7252. So four types of messages are available in this. So configurable, non-configurable, acknowledgement, and reset. Very simpler. So this is similar to an REST architecture. We are making use of an HTTP. So it's similar to an HTTP. This CoAP. Why we need CoAP? It has like the requirement for communication. So HTTP header size and the CoAP header size is very less. CoAP is going to take like 4 bytes of an header size. So as I told, like the CoAP port number is like in 5683, and there's a get push similar to an HTTP process, get push, post, delete are all the methods. And duplication application retransmissions, their consumables and all, and it will support for an especially for an UDP packets and a transport layer. So just let me tell about what is CoAP and what not is CoAP. So as I told, we are making use of an HTTP. HTTP is with an higher header size. It's going to why we have to use HTTP in my end applications, end devices. So HTTP is why we have to use CoAP for my end applications, because HTTP is the one which is going to consume higher header size with an higher header size, but CoAP is with an very less. So but CoAP is also very effective RESTful protocol, ideal for constrained devices and networks, and specialized for machine-to-machine applications, and easy to proxy from HTTP to CoAP and CoAP to HTTP. And but what is CoAP is not? CoAP is not a general replacement of HTTP, and it's not an HTTP compression, and it's not restricted to isolated automation networks. As I told, the CoAP message format, so the binary protocol, low phrasing complexity, and the small message sizes, the header size is like just 4 bytes of an header size for an CoAP. This is going to consume very less space. And also the base messaging like conformable, non-conformable, reset, and the acknowledgement messaging will be used. And the options like enable protocol extensions, number of IANA registries will be there, and type length value will be there. And the CoAP port number will be like N5683 and 61616. So very easy thing is like an CoAP will support from for a developer's perspective. It will support in Java, C, and different programming languages, C# and all. So Mozilla Firefox is the one which will support with a Copper plugin. So Copper means Copper CoAP. They will call it as a RESTful client actually. So we can make use of an Mozilla Firefox add-on to fetch the data from the end devices easily. Next, moving with an MQTT, message queuing telemetry transport. MQTT is a bit older protocol. So for an just I will go through fast with this one. Light on the network. So small simplest possible packet size for an MQTT is like an 2 bytes. The protocol was optimized for the standard underlabel, low bandwidth, expensive, and high latency networks. HTTP is relative verbose. Lots of characters are there in this post methods and all. So this is a bi-directional communication. There is a broker will be there, and publisher and the subscriber methods will be there. So from the end devices, for which are all the end devices will subscribe. No need to keep on fetching the data. If I subscribe for a specific data from an, for example, for a boiler, I want to fetch the data for every 5 minutes. Means so if I subscribe specifically with a broker, I want from the boiler number 1, and for every 5 minutes I need data from the boiler number 1. Means for every 5 minutes, once after the subscription, the data will be keep on publishing. Broker will take care of and fetching the data and then keep on publishing to the in applications. Just as a glance, application, this is one of the application protocol, and it runs atop of the TCP transport layer. So, and the binary wire protocol, no message queuing will be there in this one. Publish subscribe pattern will be utilized. So this is one of the main advantage in this MQTT process, designed for resource constrained devices. Constrained means where there is a memory and all very less available on the microcontrollers and all. UTF-8 encoded strings, so on a security perspective, and payload agnostic will be there. Keep live timer will be there, and quality of service will be available. So mainly coming to the port number, like TCP IP 1883 for an MQTT and 8883 for an MQTT over SSL will be available. So applications just like in Facebook Messenger, the chat section where users can join and leave conversation, fit well with the publish subscriber model. So Facebook Messenger is making use of this MQTT process under the hood. So this is just an high level about 6LowPAN, MQTT, and CoAP protocols. These are the emerging protocols which are running in industries. Thank you. Just let me know if any questions are there.
So if anyone have any specific questions, you can unmute and ask questions, right? Anything related to the topic of 6LowPAN and related to the IoT scenarios. Like if you want to know, please ask Adarsh, and he will be ready to answer that.
Yeah, thanks. Vivek.
Hi, Adarsh, Kalyan here.
Hi, Kalyan.
Hi. So, Adarsh, this 6LowPAN, is it being used in the industry somewhere today? As a this protocol already being used, and I've heard about MQTT and AMQP and others. Can you just cite some advantages that 6LowPAN has over others?
Yeah. So consider like an Zigbee is there, Z-Wave is there, and Wi-Fi is there, wireless technologies and all. So we can build a mesh technology. Now Wi-Fi mesh is also available, and Bluetooth is there. So these device, the Zigbee, what will happen? So just to tell you, fetch the data. Now Zigbee IP is coming up. Zigbee IP is also making use of an 6LowPAN based IP address assignment to the end devices. So as like in industry, the main advantage, as I mentioned, each end devices, microcontrollers with very less memory size, constrained devices will run with an i6LowPAN stack. So where the constrained CoAP application protocol will be there, means constrained application protocol where the less data size will be there, and also UDP communications in transport layer, and also it will make the end devices to connect to an internet. So it will all the end devices. For example, if I have some sensor, so if I have some sensor that will my water bottle having one sensor, means that water bottle will be identified within internet by its own unique IPv6 address by making use of a 6LowPAN stack. So I can fetch the data so in real time by making use of the IP, the specific IP address. So that will be a real time data. That is the main advantage.
Adarsh, which industries will benefit more, right? If you ask me, right, out of like, is it smart cities, like, or manufacturing? So which are the most adopted industries for 6LowPAN?
Nowadays already 6LowPAN is there with an smart home applications and also with an smart agriculture already there. So smart city and industries are going with an LoRa, Sigfox, NB IoT, different kind of an application based upon the application suitability. So already so many products available in market for an smart home smart home based, as well as for an agriculture based and water quality monitoring based, different are there.
Okay, any other questions? Basically, see what we are to looking also is that is next session. What we are planning is to have a use case discussion. I know, right? Because this session is more of a technical in nature. So what I requested others is to come up with a specific use case, like for example, the smart home scenario or a smart agriculture scenario. He can show us to end, right? How 6LowPAN benefits. What are the technical architecture and end-to-end scenario, so that we can come up with more questions.
Right, Vijay. This is Satish. Adarsh, good session, but like Vijay said, it's been a little on the technical side. So if we
Yes,
take
yes.
the case of a smart agriculture,
Yeah.
and you talked about a mesh network, and you also talked about having one router and several IPs. See,
End user.
how do we identify, like, how does this communication happen between the different, let us assume for the sake of example or a use case. I mean, we'll keep it to the extent that you feel comfortable, and we can handle it later or offline also.
Yes.
Like, say, for example, if it is smart agriculture and we have sensors which are taking humidity or water level, and these individually would have their IPs, or they will possibly get connected to devices like, say, Raspberry Pi. And if you say mesh network, the way I understood is, hello, can you hear me, Adarsh? Hello?
Yeah, I can hear you. I can hear you.
Yeah. So
Yeah,
when
yeah,
you
I
say,
can hear you.
oh, good, thank you. So when you say mesh, basically there'll be several devices or like Raspberry Pis which get connected, but there'll be one router or what? I mean, if they have to connect to the external world, how does that happen? Because maybe it's a very naive question, and it is basically about the mesh network to begin with, so that we can look at use cases later. Because I think overall, when you talked about these things, it looked like the underlying philosophy is based on the mesh network. Am I right?
Yeah. So like an each enter within multiple parameters. For example, as you consider like in agriculture, like an moisture will be there, leaf moisture and water content in a soil, different parameters will be there. So here what we can do is based on this application protocol like in CoAP and within 6LowPAN stacks. Mainly the 6LowPAN is to identify the device within a network. So this identifying the parameters which is supported by the end devices, like and what are the parameters which will support, like an moisture content and also the dryness and all. So for that one, the application protocol like CoAP will support specifically. If I give the IP address, it will give the complete detail about an index detail about what are the parameters the device will support, what are the sensors are integrated with the end device, and what are the data I can collect from the end devices, and is this an actuator or is a sensor with the specific IP address. All the information can be fetched, but for those things application protocol will specifically take care. So to support that application protocol in real time, the 6LowPAN will support, the 6LowPAN stack will support uh, specifically. So in depth we can discuss this offline.
Yeah,
And
sure. Thank you.
let me give a business context to this as well. Satish, you were the one who asked the question, right?
Yeah.
Yeah. So see, Zigbee. The main advantage of Zigbee is it has a mesh network, which obviously means that if, let's say, in case of agriculture, right, I have a very big farm. Let's say it has 150-acre farm, and I have these devices, which every device that has different set of sensors on them. And the idea is that every once in a while, each of the devices will send the sensor values, and they have to be, let's say, given to the farmer or the owner of the field, right? So what would happen is all of these devices, individual devices, will talk to a router. Eventually, there is a router coordinator concept here, and router coordinator endpoint end device concept. So ultimately, through various channels, all the information would go to the router, and from there you basically send it to cloud or to your own internal network. So Zigbee, so this mesh is basically that, let's say if one of the intermediate device fails, then it finds its own way of going to the router and making sure that the information is passed on. Now, the challenge with Zigbee obviously is that a mesh has to be set up. The setting up a mesh is a complex activity actually. Like the project I have actually done one project where we did Zigbee implementation using mesh, and it's quite a complex activity. Another challenge is, let's say I have again the same farm scenario where I don't want to go through this route, this mesh scenario, but I want all my devices to just keep sending data. Right? I might just have a very small sensor with a microcontroller, a very small device, and I want all of that information to just keep going out. So what that would mean is, let's say I have got 100 sensors. That would mean I might need 100 devices which are connected to internet, 100 IP-enabled devices. So that's where I think 6LowPAN has an advantage, where it uses the IPv6 option, where you can have multiple lot of IP addresses, and each one of the device gets one IPv6 address, and it can just transmit the data directly to cloud. So that's how, from a use case perspective, that's how I see it. I mean, today it's still Zigbee. Zigbee is still very popular because it's been there for a while. I think 6LowPAN is just catching up with IPv6 coming. It gives a lot of advantages. Like smart city is one of them, where you don't have to really worry about the mesh, but all the devices will just keep sending the data to some central location. Yeah, I hope that gives some idea. Hello?
Yeah, I think it sounds perfect, Kalyan and Satish, right? I think, see, what my suggestion to others should be, right? I know Satish brought up a very good, interesting point, saying that, right, let's talk about the example of a smart agriculture. So if others could think that, right, that is a good example to showcase the end-to-end value chain of taking the sensor, bringing up the architecture, how 6LowPAN will affect, not today, but maybe in the next session, right? He can dive or deep dive into the end-to-end case and showcase how 6LowPAN benefits and what is the end value benefits, so that it definitely will help the entire group who is listening to that, right? It give more insights into that.
Yeah, sure, Vijay. Noted the point. So
Yes.
I will look into the business point of view.
Yes. So I think, right, we'll catch up on 21st. As I said, you right. Next week we have one more session. I think by Kalyan is giving some more because we'll share more insights on that. So on 21st, what we'll try to do is we'll just give that use case scenario in 6LowPAN. So maybe I'll talk you offline and we can come up with a proper topic name and we share it in the group. So that, right, so people will be handy with some sort of questions or something, right? I mean, anyone wants some more, as I know, right, Satish gave us with a very interesting topic of use case, saying that, hey, I want this. Maybe some other persons will come up and says that maybe it's a smart home or smart cities or a smart environment or anything, right? Maybe we can come up with an additional, right? Maybe first 15 minutes we can talk that, and the next 15 minutes we can come up with a different use case. Maybe whatever that kind of a point, we can get the recommendations from the group, and then if they have more scenarios they want to talk, yes, we can share that ideas also.
Yeah, sure.
So before we leave, any specific things, recommendations from the group or any suggestions?
Hey, I want to ask one question.
Yeah, Yusuf, yeah, please.
Yeah, so you were saying that the IPv6 is implemented in 6LowPAN. So what is preventing IPv6 in Zigbee technology?
Sorry, can you please repeat?
You were saying like 6LowPAN is beneficial because it has an IPv6 implementation. So like what is preventing today, why are the Zigbee guys are not implementing IPv6?
Nowadays already Zigbee is also coming with an Zigbee IP. Zigbee Alliance is also coming with an IP assignment for the end devices. So but Zigbee is also making use of the same 6LowPAN process of an assignment to the IP address to the end devices. So as like Kalyan mentioned some of the how the Zigbee process will work. So that gives some idea about this.
Okay, I was just wondering, so I just asked.
Yeah, sure.
Yeah. Okay, thank you.
Welcome.
Any more recommendations? I know, right? People are hearing that, right? Any recommendations for the next session? You think, right? It would be more beneficiary. Any scenario, right? Where it's use cases or deep dive into technicalities. Anything, if you want, please let us know.
Yeah, Vijay, Kalyan here.
Yeah.
See, this IPL thing started today, so I'm really not sure if we do this at 9:30 p.m.
Yeah, I got it.
prime time.
I know, I
So
got it.
we
No,
were,
that's what I know. Before you joined it, I told him that let's shift it in the morning. So I think that's what I clearly said that, right? So morning should like 11 o'clock or 12 o'clock is a good time so people can more people can join in the morning time. I recommended that.
or post lunch is also.
No, 11 o'clock is good, right? Because if some people from the outside countries also can be joining that, it's not a problem for them.
Oh.
Okay.
Hello. Hi Vijay, Gopal this side.
Yeah.
Thank you very much for your that consideration. It will really help people like us who are joining from outside India,
Yeah.
because that will be easy for the normal timings. And second point, regarding the session and the things what in my view, what we should have a more deep dive, because today's session is more towards going deeper more into the 6LowPAN and 6LowPAN, how the technology is working and what are the things available. But apart from that, I think we can get in more insight how the 6LowPAN is differentiated from other technologies, and what are the main driver, and what are the sort of an benefit of taking this technology rather than using Zigbee, and what is the differentiation factor, why it will be in more prevalent in the near future, whether it will be in coexisting with the Zigbee, or whether it will be sort of an diluting the other communication things, because that will help us to analyze that whether it is also a one of the technology, or it will be an good technology to adopt for all the future use cases, and if the scalability point of view, how it will help easy scalability from IoT perspective. So those type of practical the aspect, if we cover in our all the sessions, it will be useful, because going more into deeper and dive into the technology specifically, it can be in the subsequent session where people are able to understand that what is the at a broad level the technology is, how it differentiates from the other prevalent technology in the industry. And then if people are more and more interested to go more the syntax or what are the key functionalities of the each technology, then we can have in subsequent sessions. But thanks very much, Adarsh. I fully understand what are the things you have talked about on the 6LowPAN in more in the technicalities. But at the same time, because it is a mixed audience, so it is just my and just a recommendation and suggestion from my end. As Vijay also said, and Satish also said, that we should have in some sort of a more use case perspective, so that people can sort of relate the practical application, and how they can sort of try to get in more insight on use adoption of this type of technology. But at the same time, we need to compare with other technology also. Then it will give in more cutting edge, that whether we should try to more leverage the latest functionality and the cutting edge thing from this technology, or we should use the existing one. Because at the moment, as you also mentioned, that Zigbee is also very much prevalent in the market, and people are still not completely sort of inclined towards 6LowPAN. Yes, there are adoption rate, but it is not a very significant.
Noted, Gopal, right? See, that's what we have recommended a two session. I know, right? See, because there are groups of people, right? I know one can be from the business, one from the technology, one come from the analyst. So there are different variety of people in the groups, right? And then everyone needs to be catered. So that again, 6LowPAN is more of a technical to me, right? Because it's not more of a like
Yeah.
deep dive into the business aspects of it. So that's where we have clearly mentioned, recommended that, right? The first session will be more technical. That's what, right? We make it very short. See if your session, right, 15, 20 minutes, right, we finished everything. We have not gone into
Mhm.
deep dive, and then we are only talking about the question and answers. So now what
Mhm.
we are, that's what we have want to take more sessions, right? See if you see, right, we are talking more on the question and answers than talking on the technology.
Mhm.
Okay, so
Yeah.
what we
Yeah.
recommended, that's what, right, me and others will work it out to come up with a specific use case. So from the next session, so maybe it will be more beneficial at that time, right? What you have given the points, right, it will be taken care, right? Why we are doing this, right? If we put that particular solution with a Zigbee solution, is it will be more recommended, or like is it Wi-Fi or LoRa, whatever it is, right? We can deep dive
Yeah.
into the aspects of the
Yeah.
differences, and which will be more
Yeah.
beneficial.
Yeah. That would be really helpful. Thank you very much for that.
Ah, okay, cool. So I think I know, right? I think the IPL is going on. I think that so many people have muted it up, and then so let's not waste more time. So what I will try to do now, I'll just